Hey guys, this is problem number 5. So a mass m equals 20 kilograms starts from rest at the top of an incline as shown in the figure below. So all you need to know is it's 20 kilograms. Basically it reaches the bottom of an incline with a speed of 9.9 meters per second. So since that's not marked on here, I'm just going to mark it. Oh, there you go. And I'm going to say that the speed right here is 9.90 meters per second. And what is the height of the incline? So we're looking for this. Let's see if I have a tool for that. Might be too thick. Wow, that's really thick. Okay, that might not work. Don't worry about that. Okay, well, we know this is what we're looking for. So maybe I can use this. Oh, beautiful. So we're looking for this. This is our height. And since this, what we're looking for is the height of the incline, and then after that, we're going to find what is the length of the incline, and we know this is a frictionless surface, so let's go over to our work. Okay, so I've done my beautiful representation. I'm just kidding. Please excuse me for my untidiness in my work, but at least it's readable, hopefully. So to get started, we need to identify our factors, which we've already done. We need to know that this is a 30-degree angle. We need to know that this is our hypotenuse. That since this is a right triangle, this is our hypotenuse. That this is your opposite side, this is your adjacent side, this is your height, and this is your length. We need to know that this is a 20-kilogram object and that it's going down the slope or down the incline with a speed of 9.9 meters per second. First, we're finding height. So we need to think of a formula that we can use for height. And you probably already saw it, but we can use our potential energy equals mass times gravitational force due to acceleration multiplied by height, and then for velocity we can use kinetic energy equals half multiplied by mass times velocity squared. So we can plug this in. I just found a simpler way to do this, so I could always write it out just quickly, and this could actually save you probably even more time, because all you're doing is always, and what I'm finding, oh, that's wrong tool, sorry. What I'm finding is it's a lot easier to actually just, before you do anything, just think out the formulas you're going to use, which we have down here, so I'm not going to write these out again. But you can just plug this in on this side, so you can just say, we know that our kinetic energy is going to be half our mass, which we know is 20. And all we need to do is just cancel on the side, so well, I'll show you as we go along. So half 20, so this is your 20 kilograms multiplied by 9.90 squared. So this is your velocity squared, and then you're going to set that equal to your potential energy, which is your 20 kilograms, again, multiplied by 9.8, and that's going to be multiplied by your height, which is an unknown. That's what we're actually trying to find for part A. So you can solve it this way and simplify down to get height. Here, as you can see, I basically did a similar thing, except I actually solved out for the entire equation, which takes a little bit more time. Here you could just cancel out your 20s, and then you're just left with 9.90 to this squared multiplied by half. On this side, 20 multiplied by 9.8, and you just divide by both sides, and you get your h. If not, either way, you're gonna get your 5 meters. So that'll be your first answer. And then we're looking for, and this is best to think out just logically, we're looking for our length, right? So since we're looking for our length, this is where our right triangle is going to come in. We know that this is a 30-degree angle, therefore we know our height, which is our opposite. And opposite over adjacent, if you don't know this, well, I'll just put that there. But if you don't know this mnemonic, this is going to help a lot. Most people will find this useful. This is SOHCAHTOA. Okay, so basically what this stands for is sine. This is all trigonometry, so this is sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So basically we just need to look at our angles and see which one we can use. Or we need to look at our sides and see which one we can use. So we know we have an opposite angle, and we know we have the hypotenuse. I mean, we know we have the opposite side, and we know we have the hypotenuse. So we can use sine, right? Because that is opposite over hypotenuse. So to use sine, see if this will draw. Here you go. We can put sine of our angle, 30 degrees, right? And this is what we're actually using in our equation. So what I'll do is, instead of actually writing it out again, I'll just show you the example down here because this might be easier to understand. We know the opposite is 5, right? So this is our opposite. That's our hypotenuse. So 5 over hypotenuse equals sine of 30, right? Because basically what this means up here is that the sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Okay, so that's exactly what we're doing here. We're saying that the sine of a degree is equal to our opposite over hypotenuse. So we just solve. All we're doing is basically moving our hypotenuse to this side by multiplying and dividing by sine of 30 on this side. So 5 divided by sine of 30 is equal to our hypotenuse of 10 meters. And that is your final answer. So I hope this helped you, and I'll see you in the next video. Bye.